going to start off with, and I'll have you do the odd problems on each of these. Odds on all 3 pages. Do you want to just do them all? Would that be better? Okay. So let's do number 2 on the first on 3A together. Yes, that's one that's not assigned. That's why we're doing it together for practice. So this is number 2 on the 3A worksheet that you just got today. Pronghorned antelope, found in North America. Best long-distance runner among mammals has been observed to travel at an average speed of more than 55 kilometers per hour over a distance of 6 kilometers. Suppose the antelope, wait a second, do number 4. Okay, no antelope, so we'll just get rid of.
Well, can you just leave it there?
Put it real small.
Just leave it there. Just leave it there.
Okay.
You get rid of the X too.
Gertrude?
Yeah, that's Gertrude.
Okay, so we're doing number 4 on the worksheet instead of number 2. So, Gertrude Ertl became the first woman to swim across the English Channel. Suppose little old Gertie, and here we'll put her in the water with her little swim fins. All you swimmers can object to this, but whatever, I don't care. So she, yeah, don't even begin to try to parse that.
Why is her leg falling?
I don't know.
It's cold.
It's very cold. It's very cold. Thank you, Jack. Okay, so she swam 25.2 kilometers east, made a 90-degree turn, and went 21.3 kilometers south. What was her resultant displacement? So what we're looking for, of course, is that. VR. And we also want to find, of course, our angle here. So now I'm going to shrink. Okay, so as review, what's your first step? VR is equal to what? C squared equals A squared plus B squared. So VR is equal to, well, square root of A squared plus B squared. And of course we got that from Pythagoras. Oops. You do. So we've just solved that, and our hypotenuse, our C, is our resultant vector. So therefore VR is equal to the square root of 25.2 kilometers squared plus 21.3 kilometers squared. Yep, 32.995908884 kilometers. And when we sig fig that, we can have 3. Ooh, this is one of those good tricky ones. What's that going to sig fig out to? 33.0. Okay, so we've got our resultant displacement. Now we just need to get a heading. We need to know at what heading. So how do we find our heading? Inverse tangent function. So we know that theta will equal the inverse tangent of our opposite over our adjacent, TOA. So inverse tangent of 21.3 km divided by 25.2 km. Get for theta. Yep. So theta equals 40.20576793. And with sig figs, we get a theta of 40.2 degrees. 40.2 degrees what? South of east. South of east. Because we're starting from the east and we're dropping south from there. So our final answer. Okay, so that's our final answer. 33.0 kilometers at 40.2 degrees south of east. Are you all relatively comfortable with doing those? Okay, not too bad. And this is called finding the resultant. Now, of course, you know we have to come out the other direction. So, what if we get the resultant vector and we want to find the components? Do we have a way to do that? By golly, yes we do, or there wouldn't be a slide. And you wouldn't have the 3B packet. So this is where we use our other two trig functions. And you will use these a whole lot more than you will as we move on in physics, as we go into forces and work and stuff. You'll actually end up using the sine and cosine function more than the tangent function, because we spend more time. This is what's called resolving vectors. So finding the resultant is one thing. Resolving that resultant into its component pieces is the other side of it. So let's practice one together. Okay, so this is on page 93. This is sample problem 3B. We're told that we have a helicopter traveling, and this is our ground surface. I'm going to draw it in green. We have a little helicopter that's traveling at 95 kilometers per hour. So its velocity is 95 km per hour, and it is traveling at an angle of 35 degrees above the horizon, or 35 degrees to the ground. So it's on this upward slope. What we want to know is we want to get its velocity on the x and velocity on the y. Now, this may seem shocking. We can break down vectors and find resultant vectors not only with regards to displacement, but we can put in velocities, we can put in forces, we can put in anything. So you treat this the same way you would a displacement. Okay? And what I very often will do is I'll draw myself a little triangle off to the side. So I know that that's 35, I know that that's 90. This is 95 kilometers per hour. What is my velocity on the y? What is my velocity on the x? This is my velocity total, or my velocity resultant. Okay? So that's the little picture I would draw myself. Well, here are a couple true statements. So we know that sine is equal to the opposite over the hypotenuse. Yeah? You would all agree? Wunderbar. So the sine of theta is equal to the opposite, which in this case happens to be the velocity on the y, over the adjacent, which in this case happens to be the total velocity. Still with me? Still good? Okay. So now we can solve for the velocity on the y, and I'm going to get rid of this piece. Cut. Move this guy over. Well, that means we can solve by saying that the sine of theta times the total velocity equals the velocity on the y. Fairly straightforward, yes? Okay. Okay, so we've rewritten that to say that the sine of 35 times 95 kilometers per hour is equal to the velocity on the y. Stick your thumb on your forehead if you have a number. Just because it's fun to play with you people in the morning. Okay? No number yet? Okay. Okay. Do you know how to put this into your calculator? On the TI 30 multi-views, if you enter the following button sequence, sine, and then it will automatically pop up a parentheses, and you enter the number 35, and then you enter this, and then you enter 95, you're going to get the wrong answer. You have to do one of two things. You have to close this parentheses, or enter this part, then hit equal, and then multiply by 95. So it's just an order of operations thing, but if you're moving fast, you can forget it. Okay, so what do we, let me get rid of this stuff. I'll just shrink it and stick it over here. So what do we have number-wise? 54.48976145. What are my units? Kilometers per hour, right, is equal to Vy. Now, does that vector have a heading? North? Really? Up! Up. Just up. Up into the air. Because remember, we're looking at this helicopter on a side view. We're looking at the horizon, the surface of the Earth, and this thing is, coming up off the Earth at an angle. So we're looking at it at a side. North, south, east, and west are meaningless here. But that's the velocity on the y, is 50. And when we sig fig this, what would we get? 54. So let's do that. Okay, so we've got our answer. How are we going to go about getting the answer on the x-axis? Same thing with cosine. Yes, sir. Oops. Okay, I think we can all agree that cosine of theta is equal to the adjacent over the hypotenuse. Wunderbar, and in this case, the adjacent is the velocity on the x, and the hypotenuse is the total velocity or resultant. So we're going to do the same exact thing we did for the other one. I'm going to skip a step algebraically because I think you can all handle it. And if it confuses you, then just come talk to me later. That cosine of theta times the total velocity is going to give us our velocity on the x. Seem reasonable? Okay. So cosine of 35 times 95 kilometers per hour equals our velocity on the x. Do you have a number yet? Okay. What would be our heading for this? You could say along the horizon. You can say something. We don't know if it's north, south, east, west, left, right. We have no idea. So all we can really say is that it's, and it would sig fig out to what, 78 kilometers per hour along the horizon is v sub x. So we now have both of our components. This becomes something that you use constantly when we start getting into force problems in Chapter 4, and you use it a lot here. We're going to start using it more and more and more. Comfortable? Okay, so you know how to find the resultant, you know how to break apart a resultant. I'm going to give you time to work. I will assign 1, 3, 5, and 7. So on page 94 you have 1, 3, 5, 7, then you have the 3B worksheet odds. Okay, and this will all, of course, be a big chunk of stuff due sometime in the future. Okay, you have time to work, and I'll float around and help you as I do other things.